Good afternoon. So, this is Junichiro Horikawa, and this is a weekly live stream, tutorial live stream for Houdini. And this is 159th episode. The topic is about creating some kind of bouncing balls inside a cage object, like you see in the display right now. That capturing object could be anything solid, could be sphere, could be boxes, could be anything, like even in test geometry shapes, if it's solid, right? And things that you can control with the setup that I'm going to try today is such as the size of the ball, which is bouncing inside the object, or number of balls, bouncing balls, a random seed, and a parameter to control how much it pushes the bounding box or the bounding cages. If you increase the amount, you see a bit more pushes happening to the boxes. You can also go exaggerated like this. Or you can also increase the area, how much of the area will be affected by the ball bouncing when it contact with the box, contact with the edge of the surface. I mean the surface itself. You could also control the size of this capsule shape when it's running from one side of the surface to another side of the surface. You could, by making this smaller, you see the capsule size becomes smaller. If you make it bigger, you'll see something like this. Just to this is kind of an effect to show that the ball is like running fast. And you could also control the length of the cylinder. Currently this is a bit too much, I guess, but you can control this ratio to set the right amount of the length to make it look like it's running from one side to another with a quick speed. Another parameter, which is, this is a random, this is the minimum and maximum number to indicate how many paths you will have for each each balls. If you make it small, if you make a small number, then you have, in this case, you have only 5 paths for each balls in order to run inside a box, meaning you have 5 bounces within the whole animation frame, and it will be looped. If you make it bigger numbers, you have more bounces within one whole loop. Okay, and this is to indicate the randomness between 5 to 19, so each balls have different number of bounces in this case. So that's pretty much what I have as a parameter, and maybe while I'm implementing this from scratch, I might be adding some more to this during the live stream. Anyway, that's this. Today's goal is to create something like this from scratch. Yeah, well, I'll use this as a cheat sheet in a different display. Okay, so that's my goal today, and let's start creating the setup. Now, the idea is pretty simple. You're just going to create a bounding geometry. Could be anything, any geometry you like, unless it's a solid. and place any number of points inside the geometry, which will be then later converted into a ball. Okay. Then what I'm gonna do is to randomly create a path for each of those points within this geometry. So what I'm gonna do is to create a bunch of random points on top of a surface and connect these points as a closed polyline. Then I will let these balls go through these paths. And while it's going from one side to the other, let's say from this point to this point, I'm going to try to transform the sphere so that it will become a capsule-like shape towards the goal. So first, when it is on the edge of the surface, will be just a sphere, but then in the middle of the path it will try to be a capsule to make it look like it's moving in a fast speed. Then becomes sphere again when it contact with the wall. Now another effect that I'm going to create today is when the sphere touches the wall, I'll try to kind of morph or create some bouncing effect to the box itself to make it look like some kind of a soft body shape, which is gonna be pretty simple. And yeah, and probably I'm going to use a vector which is combining the vector towards there and the vector towards there and adding those vectors together to specify in which directions this morphing will happens. Okay, that's the basic idea, and all the rest I'll explain in the detail with the Vex. Yeah, as always I'm going to use Vex for this setup. Okay, so let's start with the simple shape. Maybe I might want to do with a bit more complex shape first, so that you will be more versatile when it is about creating a path inside the closed geometry. So I'm gonna start with the pig head as a bounding box geometry. Okay, and within this geometry, the first things that I want to do is to create a path for the ball to bounce. Okay, so let's do this. And it's a bit tricky because this has a lot of concave shapes, like here or like here and so on. So it will be easier to create a path if it's more of a convex shape like sphere or box, but in this case, in this kind of a complex shape, might going to be a bit more harder. So let's see how we can solve that issue. Okay, let me save this to today's folder. Okay, so first thing first, I have just created the bounding shape. I am also going to create a sphere that I'm going to make it bounce inside this bounding shape. So let's make it a polygon. Make it a bit smaller, small enough, so that it can run inside the geometry. Okay, and let's increase the frequency a little bit. Okay, so let's also create a null node to have a bunch of parameters that I would like to control globally. In this case, I would like to control this scale for the sphere. So let's do that. And let's also make the radius equal to 1 for the sphere, so that the uniform scale itself will be the actual radius. It'll be much easier to control with that. Okay, so let's move this uniform scale to a controller node, controller null node. Let's call this ball size, or ball radius. Okay. And then, okay, next, since I would like to create a path inside within this geometry, and in order to create a path, I'm going to use a bunch of points connecting as a polyline. But if I just do it as it is, there is a problem. Currently, I have just created the closed path to on top of the surface, but if I try to move the sphere on each of the point, you can see that there is intersections happening here. So what I need is to have the path inside the geometry, not just colliding with the geometry itself. So in order to achieve that, I have to kind of offset the geometry by the radius of this sphere, so that the path will not so that when the ball goes on top of the path, it will not collide with the surface itself or intersect with the surface. So to do that, I am going to first of all convert this geometry, pig head geometry, into a BDV. To be able to offset, or in this case using a delate or dilate function. Let's make the voxel size a little bit smaller, and let's use VDV reshape SDF. Oh, before doing that, I'm going to make it sure that I am going to fill the interior of the BDV. Then I'm going to use a road. Then use wall space units. Then copy the ball radius, paste it to the offset, and as a result you'll be able to offset the surface, and the surface you get as a result is where you can put the ball or points for the ball in order to create a path. So let's convert this back to a mesh. Then try using a scatter node again and see how the points being placed together with the geometry, and you see that the balls are now within the geometry, merely touching the edge. Okay, so that's the first step you need to do in order to create the candidate points for the path. Now, another So the next step is to kind of modify the path that I'm going to create for this very geometry. So let's increase the number of points on top of the surface, and let's see this as a polyline. See how it looks like as a path. Okay, so I want to use this path as a loop animating path, but there's a bit of problem with this path when it's being used with a concave geometry like this one. Now currently it looks fine, but if I change the seed, at some point you'll see some problem like these, which is penetrating over the mesh. So from this point to this point, you're going outside the mesh at one point and then go inside the mesh again, which is not ideal as a effect that I'm going to create, that I would like to create. I only want the ball to bounce inside the geometry. I don't want to make it go outside geometry like this. So things that I need to do here is to modify the path somehow, which should only create a connections within this geometry. Okay, so that's what I'm gonna do next. Okay, it's a bit of how do I say? It's a bit difficult to tackle with this kind of a problem. So let me explain what I'm planning to do. Okay, so let's see. If I have a shape like this and want to create a bouncing path, something like this, but not like this, which is intersecting on the edges. So in order to achieve this optimized path, what I'm going to try to do is to kind of a brute force way. First of all, I'm going to let me see how I managed to do that. Okay, so what my plan is, first of all, as previous method, I'm going to pick random points on top of the surface with the number of points you decide. Okay, and then each point has the number, the order. So let's say one starts from 0, 1, 2, 3, 4. Okay, if you use scatter node, the order will be random. Then the next step, what I'm gonna do is to try to connect from 0 to 1 and 1 to 2, 2 to 3 to 3 to 4. So in this case, I'm going to try to connect from 0 to 1 like that. And then the next step that I'm going to try to do is to try to connect from 1 to 2. But as soon as I try to do that, there is an intersection happens right here. So when that happens, I'll stop the path creations right here. So I'm going to replace this 2 right here. Instead of going through to the original second point, I'm going to create a new point for the second point and make it as a a next point. Now from this point, the next point that I want to look for is number 3. And then again, I have another intersections happening. So again, I have to move 3 here, using the same rule. Then the next step is to look for the 4, but again, I have another intersections, so I have to make it like this, replace point number 4. Then if I have connected every point, then the last thing you would do is to look for a first point, number 0. So from 4 to number 0, I am able to connect. So as the result for these connections, you're just going to get kind of a 2-line connections. Just go from this point, go to this point, and again go back to 0 again. So using this algorithm, there is a chance that you are going to get a really smaller than the point you have applied to the surface, and and there is a chance that you're not getting any pass as well. If from number 4 to number 0 doesn't allow you to create a pass, then that pass is a failure. So you have to look for another one. You have to recreate the points on the surface and redo the same logic again until you get a closed pass like this. Closed pass could be just 2 lines, or could be 3 lines, could be a multiple number of lines. But as long as it's closed, that's fine. If it's not closed, then you have to look for the other candidates. So that's what I would like to do as a logic. Probably making a feedback loop like logic in order to look for a closed curve until you find something. And so let's do that. So currently this is failing. So the logic here is, first of all, create a number of points on a surface, like using a scatter node. Then iteratively connect points with the order. So in this case, the point has the order from 0 to 1, 1 to 2, 2 to 3. I'm trying to connect those points and check if there are any intersection with the original geometries, and if there is, then recreate the points where it has been intersected. Okay. Actually, the things that you need to check with intersection is this one, I guess, or this one. Yeah, should be this one, because this is where I'm going to create the points. Yeah. So let's try doing that. So what I'm gonna do is to use a attribute wrangle. Let's use it as a detail, since I'm just going to create the lines from scratch, and I'm going to connect the points as maybe a surface to a second input, points to a third input. Let's also create a normal vectors to a surface as a point. Okay, and let's call this create animation path. Okay, so let's get the initial informations. First of all, I'm going to get the initial position from the scattered point. So the first point coming from third input 0. Okay, and let's add a new point to that positions. I'm going to create a point by myself because I'm not connecting to a first input with this triangle. So I have to create everything by myself. Okay, and let's also create a variable called count, start from 0. And this will be used to track in which iterations we're in on the loop. Could be just using I, but yeah. And then let's also get the number of points that we have. So you can get it from the second input using the third inputs using n points. This is the number of points you have. Okay, anything else? Let's try to use these information to create a loop. So you have a number of points. So I have just created the first points right here, and the second point will be where? Right there. Okay, so the first try is to create a line from 0 to the second point and check if there is any intersections with this geometry. If there is any intersections, then you have to stop at where you have intersected. Okay, so let's try doing that. So to get the next point, I'm going to create a value called next, which I'm going to add 1 to the count. And in the end, you want to go back to original point, which is index 0. So I am going to create a modulus like this as a next point. So in the last loop, in the last iterations of the loop, you're going back to 0. The next will be 0 in the end. Okay, and let's get the position using this next index. Okay, so should be the second points for the first iterations of the loop. Okay, now let's also get the normal vectors where the initial point is in order to use it for intersection. So the normal, I think I'll just use a UV sample from second input, which is the surface. I'm going to get the normal using P as a sample, and let's use positions to sample the normal value right here. Okay, and then I am going to try to do the intersection analysis. So use intersect to try to intersect with the surface. Then from the current point positions, which is currently right here, I'm going to make this point position go inside the surface a little bit by subtracting by the normal a little bit so that there's not going to be any intersections at this point. If you don't do that, there's a chance that you're going to get intersections right here, which gives you a kind of a errored value. So let's make sure we do something like this. And we also need to define the direction. The direction is from this point to the next point. So, which is the next point is end pos, and the current point position is position. And let's also make sure that this is smaller than, a little bit smaller than the original lengths, because if you just go from this to this point might be treated as an intersected point, so should be a little bit less, a little bit smaller than this vector value. So I'm going to multiply by 0.95 just to make it a little bit smaller. And as a result, you get interpositions and UV. Okay. Now, if there is an intersections, the inter value will be more than 0. In that case, this interpos is where you want to create a new point as a next point position. So I'm going to replace the end pos with the intersected position, then create a new point where you have as a next point position. Okay, and seems like the new point has been created here, but this is within the loop, so let's make it just one iteration for now. So it goes from this point to this point, is that correct? Okay, so looks like it has just connected from this to this, from point 0 to point 1 without any intersection in this case. Okay, that's fine. Now let's create a line between the point 0 to point 1 as a connection. So using add prim polyline from the CPT, which is the original point position, point number, then the new PT, like this. Okay, and as soon as you did create the first line, the next step is to look for the next point. In this case, I have just done from 0 to 1, so next try that I want to do is from 1 to 2 to a surface. And I can obviously see that there should be an intersections from 1 to 2. So that will be a good example. What will be next. So to go for the next loop, I need to update a CPT to a new PT. And I also need to update the position to a new position, as well as the count to a next one. Okay. Now let's increase this to 2 to see how it goes. So in this case, the line has stopped right here, and if I checked with the geometry, you see that it didn't go over to the original 2, but just stopped where you had the intersection right here. That's good. Now the next step, you want to connect with number 3, which is right here. And from this point to this point, I probably don't have any intersection, so it might work. Let's try. So I just need to increase this iteration. So let's just make it back to the original numbers, to the total number of the points you have. And let's see the final result. Okay, so this is the final result you got. And you see some issues here that 0.9 and 0.0 should be connected, but currently it's open surface, open a curve. That is because you couldn't connect from this point to this point because of the intersections, or it's outside the mesh. And I realized that there is another problem here which hasn't been detected as an error, but this is also error, which you have a connection from 6 to 7 which goes outside a mesh. So I think I need to fix that as well. Let's check that. Let me change this to number here. Okay, so this is where it happens. So I assume that this starting position of this intersection was a bit outside of the surface rather than going inside. So I think that was the reason why this happened. Let me just check if that's the case. So let me copy this value, which seems to be the problem. I'm going to create a temporal point to check where this point is being created. Okay, as you can see, well, maybe this point is the one that's been created, and it does look like it's inside the face, the surface. But let me check. If that's the case, then maybe the intersection precisions wasn't good enough. Okay, well, no, it's just outside the surface, as you can see here. So that was the problem. So in order to solve this, I mean, this error happened because of this pointy surface on the edge. So maybe fixing those edgy surface might be the fastest way. So I'll just try to smoothen out these edges by using something like smooth, see if it's gonna fix it. Okay, so the smooths didn't really smoothen out the surface part. Let me try with attribute blur. Not so good, is it? Or maybe before doing a convert VDB, I'm going to apply some smoothness to a VDB itself. And let's also increase the voxel size a little bit using VDB smooth to smoothen out the edge a little bit, like that. Okay, then convert this, you get the smooth edge, and now you don't get any intersections anymore. Although you still get a issue that this point and this point is not being connected. That is because I think there is an intersections when you try to connect with the last point to the first point. So in that case, my plan is to just throw this option away and look for the other options just by changing the global seed. Okay, at some point you should be able to get a path that should connect as a closed curve. Let me see. Seems like this should be able to connect, so maybe the way I write is not correct. Let me check. So I don't need this temporal point anymore. Oh, forgot to make this back to the original point number, so that was the reason, I think. Okay, now In some cases, it connects as a closed curve. In some cases, it does not, like this, when you have an intersections. So things that I want to do here is to look for a closed curve. The first closed curve that I found will be a things that I want to use. Okay, so in order to do that, I'm going to create a for loop for this setup right here that I have. And each iterations, I'm going to change the global C's, and as soon as I found the closed curve, I'm gonna use that one and stop the loop. So to do that, I am going to use a feedback loop. I'm going to use a for each number, then connect the mesh from the convert VDB to the input, and then as an output give you the final output here. Now I just want to get the final curve result, and I don't really need the ongoing process while doing the loop. So I think the way I should connect the input is something different. Okay, so first of all, I'm going to change this to fetch feedback each iterations, and for this one I'm going to use fetch feedback. Okay, and this connections is not preferable, so I think I need to change it. Think I need to connect it like this, and I'm going to connect the input as a null node. Let's call this check the closedness for the curve. Okay, and for each iterations I want to change the global seed here. Let's use the iteration value from this for each count. So detail for each count iteration 0. I could probably multiply this by some value plus some seed if you want to change by yourself. Okay. Now let's also add with some random value here. Okay, so if I have 10 loops, each 10 loops will check if the curve will be closed or not. Okay, and things that I need to do in order to stop the loop is to check if the curve is closed or not, and you can check it by checking the distance between the first point and the end point, and if the distance is close enough to 0, then you can stop the loop. And let's check that right here. So let's have a first point positions as position stored into a variable, and if I finish processing this loop, the final point position should be this pos. Okay, so checking the distance between the final positions and the first position, you should be able to check whether it's closed or not. So if the distance is close to 0, then that means it's closed, and that means you can stop the loop. So I'm going to create a detail attribute that you can stop the loop. as an integer. And let's check that value from this null node with this stop condition parameter. So detail check closed stop. So if this is equal to 1, then as soon as you get those stop conditions, then you can stop this loop. And you can see that it just stopped after 2 feedback iterations, feedback loops. And since this loops stops automatically as soon as it finds the closed loop, you can make this loop number really high. Still runs fast if the geometry is not that so complex. Okay, so let's try adding additional seed value here, random seed value here, to see if I can change the variations, and still you get to get the closed curve. So let's copy these parameters and paste it to a scatter node global seed. I'm going to add additional seed number here so that you can control, you can choose what kind of closed curve do you want to get randomly, and you still get a closed curve which is within the surface. Okay, you're never going to get a curve which is intersecting with this concave shape. That means you can make sure that the ball is not penetrating the surface, even if the geometry is pretty complex like this. Okay, let's try with the other shape. Rubber toy. Okay, so this is I eroded shape, and it still is within the shape. Yeah. Sometimes it'll go in this way, but that's fine. What about the squab? Should also be fine. Yeah, looks fine. So now I am able to create a closed curve on a kind of a complex shape, any kind of closed shape. Let's go to the next step to actually create the animation using this pass as a pass for the animation. Right, so I only have one path right now, but I could make a multiple path later using additional for loop, but for now I'm just going to create a single animation, then make it multiple later. Okay, so let me also check the point numbers and primitive numbers. Okay, so there is a chance that the point between the end point and the starting point of the one pass is too close, which makes the animations a bit look going too fast or too slow within this path. So for these paths, I think I'm going to merge it or fuse it together if the point is too close to each other. So I'm going to create a fuse node, and I'm not actually fusing, but I'm just going to snap it with a kind of a number, big enough numbers to combine these two close points. let's say 0.2. Yeah. Or 0.1. I think this is still a bit too close, so I'm going to go with 0.2. This could be parameterized, so I mean, if you insist having a small path, then you could make it smaller. Well, let's have that as a parameter. So let's call this fuse dist for the path. Maximum could be 1. Okay. Now, since I didn't check the fuse snap points, you still have a number of points available at this point. The reason why I didn't check this is because I didn't really want to reorder the line. I mean, once I do this fuse snap points, there's a chance that the point order of the line will messed up. So that's why I kind of didn't want it to use fuse point, but I'll, especially if when I use resample node, but I'll use it later. So next I'm going to use a convert line. It's already a line, but by using a convert line, I'll be able to get a primitive attribute rest length, which is necessary in order to create a nice animation or controlled animation. So I'll do that. Then I'm going to use a resample node, okay, to add a bunch of points within each lines. I'm going to use maximum segments instead. Okay, well, now that I think of, I am not sure if I really need to resample. Previously I used, probably I don't really need to resample unless you want to change this curve, change this path to something like curvy path. If it's straight, probably I can go without the resample, maybe. Let's ignore this for now. And then you could use fuse at this point, which will just merge the point. Okay, and at this point, okay, and for this fuse, the first fuse, I think I also wanted to make sure that I use the original point number instead of just using average, to make it sure that the point is on top of the surface. Okay, and I am now wondering if why not I should just fuse it right here. Isn't it the same result? Now that I think of, probably it is. Let me check. So if I use a resample node, you see a point number being created, and if it starts from 0, and if it's going, if the number is incremented in the right order, then that's totally fine. Last time I checked, there was an error on the last line, but in this, currently when I'm looking at it, it looks fine. Let me try to change the seed, see anything changes. Okay, still good. Okay, well, still looks fine to me. Okay, why not then go with this process? Well, anyway, I don't really need the resample. I just need a convert line. Okay. Convert line is fine, right? Hopefully. Maybe instead of using convert line, I'm going to just use a measure node, just in case the convert line might make the order flipped. So to make sure that's not gonna happen, I'm going to use a measure node instead. And calculate the parameter, and let's also use clean, because I might have unnecessary empty primitive, just in case. Okay, now I think I have enough information to start doing the animations. Let's create one. Okay, so I'm going to create one point, and this one point is going to be running on top of the path with these timeline. And in order to control this point positions, I'm going to use point wrangle. So I'm going to connect a point to a first input to the point wrangle, and to the second input I'm going to connect the path. And let's try creating, let's try to control this point moving through this path. Okay, now first thing to think about is how to decide in which timing the point will go round on top of the path. In the previous examples that I created, I have divided the timeline based on the number of lines. So if I have 5 lines, I'm going to divide the timeline to 5. So 1, 2, 3, 4, and 5, and use each sessions to run the points from start to end, start to end, start to end for each line. So that was my plan. You could take an account of the length of the line to kind of divide the timeline based on the length ratio, but that will be a bit more complex, so I'll try to do it with the even divisions. So each line stands for I'm just going to use the number of lines to divide the timeline and use those sections to animate the point animation from start to end. Okay, that will be easier. If maybe if you want to have more controls, using length ratio might make more sense. But for now, let's go with this. So first thing first, I need to count the number of primitives you have. So in primitives coming from second input, and let's get the time based value from the frame. So you have frame, and actually it'll be easier to use a normalized value. So it's divided by f end will make you a value in between 0 to 1, right? Now that's fine for now. And I also want to calculate how much of a time you use for each line. So the maximum time amount in this case is 1, because I have normalized here. So this goes from 0 point something to 1 with this calculations. So the maximum value of this timeline is equal to 1. So if I divide the maximum time amount by the number of lines, you get a step timing, or time for each sections, time amount for each sections, like this. Let's call this step T. So if it's currently, I don't how many lines I have. So I have 8 lines. So I have just divided 1 by 8. And that value is the corresponding time amount for each line. Amount of time you can use for each line animation. Okay, now the things that I want to know next is, while I'm changing the time step, timeline, time frame, I need to know where the point is. I need to know where which line the point is currently on, and then within that line in which positions the point should be placed. So I need to know 2 informations. One is the number of primitive, index of primitive, and another value is the address within that line where the ball should be placed. And the number of primitives can be calculated by just dividing the current time value by a step T value that I've just calculated here, then get the integer value out of this. Will give you a value based on where the point is, where the time is, when the time is. You can get integer value starting from 0, 1, 2, 3, 4, and so on. And then in the end, you might want to go back to 0 when it reaches to 240 frames. So should do like this. Okay, to be able to create a loop animation. The next value you want to know is, from within a single line, you want to know how the time will be converted into the position from the starting point to the end point. And that can be retrieved by using a frac value by dividing T and step T. Okay. Will enable you to get just a fraction of the value, which indicates the kind of a UV value, the U value for the single line goes from 0 to 1. Okay. And hello, I have a comment. How much RAM do you have in your Mac to handle Houdini workflows? Forgot, but 64 gig, I think, yeah. I don't really need that much RAM. I mean, the things that I do, I don't really do simulations that much, the DOPs that much. If I need to do those, maybe you need better RAMs, but the modeling that I'm doing, something like this, doesn't necessarily need much memories. Okay, where was I? So I have just created the 2 informations. One is the integer, one is the fractional value, which is indicated as a primitive UV value for the curve. So let's use both of these values to indicate the point positions for the sphere. Okay, so the actual positions can be retrieved by using prim UV checking at the second input, which is the path. Want to get the point positions. Primitive number is n. The UV is F00. Okay. And let's try to replace the current point positions coming from the first input to the positions that I have just estimated. Currently right here, and if I play it, you see that it's running smoothly on top of the line. Okay, so first step is good. The next step is to control the speed, the moving speed within each line, so that it looks like it's jumping from wall to wall. Currently it just looks like a train movement, doesn't really look like it's jumping. So that's what I want to fix next. Okay. Now, so in order to control the movement, the speed, I think I would like to use a ramp parameter for that. Okay, so let's try using that. And where should I place it? Okay, so instead of using f as it is, in order to specify the point positions, I'm going to create a new value called u. That stands for the curve u value. And I'm just going to use a chramp parameter to remap the f value that I have here. And instead of using f, try using u as a u value. Okay, now currently this is a straight line as a ramp parameter, but by controlling this curve, I'll be able to control the speed, how much point moves in each position. So currently it moves linearly like this, but for each line, probably I want to start the line fast, move fast initially, then slowly stops at the end and collide with the wall. So to do that, I need to kind of modify this linear line somehow, like this. Let's try. And you can see that initially it goes fast. Maybe start slowly and go faster in this case. If I go like this, it goes faster initially, then slowly touching the end. So not sure which one's better. Which is more natural. And currently I think the time is a bit too long, so let's make it like 90 frames. Yeah, start to look like it's jumping. Both ways looks fine. I mean, it's kind of hard to decide which one's better. This is not that good. I'll try with these curve for now. Okay, well, we can come back later if it doesn't look natural in the end. Okay, at this point I can try copying the sphere, the original sphere that I want to move. Wait a minute, I think I have deleted. Oops. Okay, I shouldn't have deleted. Okay, I have the radius here. Copy it. Paste it here. Okay, so let's copy this sphere to the moving points. Like that. And let's also combine it with the original geometry to see if it's going within the geometry. It looks like it's bouncing in within the geometry. Okay, let's make the alpha channel set for the geometry. Oops. Like this one. Okay, so how does it look like? Okay, so it does look like it's bouncing within the geometry, so that's fine. It looks fine for now. Okay. So going back to the point, next step that I want to do is to create more of a speedy trail. So things that I want to do next is this one. So when the point moves from one place to the next place within these trails, I want to make the sphere like a capsule shape, more like showing it like as a motion blur shaped. It's not the actual motion blur, it's a geometry, but I want to make something as a geometry to make it look like it's moving fast. So if it's just a circle, it's not that, I mean, it does moving fast. It is moving fast, but it's not that interesting. So as a motion animation, motion graphics, so let's try making, while it going from one place to the other place, let's try to make this sphere more like a capsule shape. Okay. So to make a capsule shape, how do I do that? First of all, I need to know in which directions the point is moving to, so that I can align the capsule to that direction. So let's make the directional informations to that point that I have it right now. So the directions can be retrieved by checking the current primitive that I'm running on, which is this one. And from this primitive, I can get a point list, the starting point and the end point. So let's get that information, shall we? Can get the points from prim points from the second input n. Okay, and the first point is this one. The second point is this one. And then checking the directions by subtracting two positions. I think I can just normalize it. Wait a minute, maybe I'll keep the directions as is without normalizing it, because I can also use the distance of this vector value. Okay. Now that I have these directions, let's set the normal attribute for the current point with the normalized value of this direction. Okay, let's check if the order of the sphere, if the orientation of the sphere is changing. Let's change the sphere to polygon mesh, which will be easier to see. And I think it's not changing, so maybe something is wrong. Let me check the attribute. Okay, the normal is 0, so I realize I have to get from the second input. Okay, now I have some value here. Okay, and let's check how the ball is animated. Okay, so maybe I want to make this part going forward toward the path. So I think I need to change the orientation of this ball. Let's make it z-axis. Okay, looks fine now. Okay, that looks fine. Next, I kind of want to modify this ball to change its shape where it's running in between the path. Especially in the middle, I think I want to make it longer capsule shape. So what will be the best way to do that? First thing first, I think I need to create the capsule shape, right? So let's do that. Let's, instead of using sphere, in order to use a capsule, create a capsule shape, I think I need to combine the tube together with the sphere, so let's do that. And let's align it together, set the radius to the same shape size. Let's make this 1 and 1, set the radius scale to equal to this sphere. Okay, then make the length height smaller, like that, 0.01. Okay, and or maybe 0. Wait a minute. Let's make it really small, like 0.001, like a line. And then let's split this sphere into 2 using clip. And change the directions to Z direction. And try to combine with this tube. Now I think I also need to make sure that the column number is the same. Okay. And it's a bit hard to see if it's being connected, so let's increase the height temporarily. Like 0.1. Let's move the tube with the match size. Justify with the Z value, Z max. Okay, so that it will touch with the clipped sphere, like this. Okay, then I'm going to move this whole thing again using another match size. This time minimum Z. Then use a other side of the sphere. Use another clip, or you could just use a mirrored shape of this sphere. Zero, 0, 1. Don't keep the original, but merge these together. Okay, to make a capsule shape. Okay, then kind of need to create a setup so that I can scale just this part somehow. How do I do that? How do I actually do that? Let me see. What will be the easiest way to do that? I guess. I guess, because just copying this might not be a good idea. So instead of copying this to the point positions, going to do a two-way copying. First, I'm going to copy the line to this positions. So as a result, okay, first of all, let's change the order. Could be a Z. Okay. And I think it's the other way around, so and I need to have 3 points to this line. So the middle points will be having a tube geometry. The other 2 points, you get a half sphere geometry. And on only the middle part will give you a scale informations. Have the scale informations. And on the end point, we'll get just non-scaled points, or uniformly scaled points. Okay, that way I think you should be able to control how the geometry should be copied to that specific moving point. Okay, so let me check with the original curve how it's moving. Okay, so I think I want to flip the directions. Okay, so looks good. Currently the length of the line is too long, as you can see. I think I can just start the line lengths. Well, start with lengths equal to 1 is fine, I think, because I can control the lengths by setting the p scale to the point which is being used with the copy to points. So let's create this p scale value, which is going to control the length of this actual line within this path. Okay, so in order to control the p scale value, I think I could use this f value again. So let's create additional ramp parameter for the f value in order to control the p-scale value, which is going to be used to control the length of the line. And it should start from 0 lengths. In the starting point of the path and the end point of the path, each line path, the size should be 0. Then gradually becomes some lengths on the middle, then go back to 0. So more like a sine wave stuff, but let's use ramp for custom modification. So p-scale, ch ramp, pace ramp using f. Okay, so you got another parameters, and this case you want the first point and end point to be 0, so you need to have a mountain-like shape curve, something like this. Okay, let's try with that. I'm just going to apply p-scale, see what happens. So start with 0, becomes longer, but you can see that there's a bit of problem right here. It becomes bigger too fast, so I think I need to shift this mountain to the right side so that the timing when the lengths become longer will be later, like that. Okay, looks fine. The total length is too long right now. The final length is too long right now, but the timing seems right. Something like that. Okay, so let's also control the line length, the maximum line length, which you should take an account of the current line, the path lengths, which you can get that information from this value here, the direction. The length of this direction is actually the length of this path, the edge path. So you could multiply the lengths of these directions, and maybe not using the full lengths. Maybe using the full lengths might not be a good idea, so multiply it with some ratio value like 0.5. And now you can kind of control how much the line should length. Okay, looks really fast. Okay, looks good. Now I think the value that I have here could be parameterized, so let's call this, I don't know, trail length ratio. If it's 1, I think it's gonna be too long, so it should be less than 0.7 or 5. Let's go with 0.5 for now. Okay, so now I have those lines. Let's try to copy those geometries that I have here to each of those point informations. Okay, so to do that, I need to make sure that those points have a normal informations as well as the p-scale informations, the scale informations. Okay, so normal informations can be retrieved by just using orientation along curve node, which will give you a tangent vector as an n normal value. So you get something like this. And let's try copying the sphere to that point, the half sphere to that point. Okay, so I only want to copy to the last point in this case. So I know that I only have 3 points here, so I can just say copy it to number 2. Right? And for the other sphere, which is the mirrored shape, I can copy it to number 0. Right? And for the middle part, middle cylindrical part, I can why is it so big here? Okay, so for this cylindrical part, I can copy it to a middle point. But in this case, I think I need to set the p-scale. If I just copy it, and I think I don't really need a match size anymore. And if I combine these 3 geometry together, okay, so it looks like this. So what I need to do is to control the size of this cylinder here. In order to make it easier to control the size, let's change the height to 1 so that it will be easier by scaling it. Control the size by scaling it. Okay, so for the middle point, actually the size is pretty simple. You just need to calculate the total length of this primitive of this line that I have it right here. So let's calculate that using measure node. Okay, getting the parameter. Okay, so this should be the scale value used to control the cylinder. So let's use that for a middle point. I'm going to use a point triangle. So selecting just the middle point number, then get the parameter value from the primitive. So let's access to the primitive number. Then get the parameter value. Then create a vector scale value. In this case, there will be 1 parameter, I think. Then set it as a scale attribute. So I just need to scale in z directions. X and y can be the same value. So just scaling by 1. It's fine. Okay, now let's check what happens. Okay, where did the spherical shape go? Okay, I realized that I also have to set the scale for a point, end point as well. So let's forget about using a group, filter it with a group, and by doing that, these end spheres also scaling. So in order to make sure only the middle one will be scaled, let's create the conditions here. If pt_num is equal to 1, scale it like this, else use just 111. Okay, and now it should work. Okay, moving like a worm. Alright, so let's check it together with the line, see how it moves. Okay, looks good. And you can control the length of this trail with this ratio that I set here. Okay, and if you want to change how it moves, now this doesn't really look natural, is it? Yeah, I think this is better. More like it's moving in speedy way. Okay. Now I also thought that when moving fast, when showing the trail like this one, making these trail shape a little bit smaller than the original sphere might make it a bit more speedy, I thought. So let's also include that kind of functions here. So in that case, what I need to do is controlling these value, x and y value, for both sphere and the cylinder. Okay, so I guess I should do it right here. But in order to create a scaling value, I think I need this f value, or I can reuse this ch ramp value as is. So let's have this value here and to promote it to a attribute, some kind of attribute, so that I can use it later. So let's call this PS, and I'm just going to promote this one, this value here. And I'm wondering if I need a length value. I don't know, maybe not. I'll just use this one. Okay, so as a result, after processing somewhere around here, I should be getting this PS value as a point attribute. So let's try using this to control the size of this shape, which is x and y scale. So PS is f at PS. Now when it's at the edge, I want to make sure that the scale is 1. So if it's 0, 1, make it 1, when the value is actually 0, and make it something like 2.5 when the value is equal to 1, and use this one for x and y scale like that. And you'll have something like this. Really look like a worm. Let me check. Okay, I might want to scale this part to PS as well, so let's call this PS. Okay, looks better. Or not. Maybe I could still keep this one to make it a bit more pointy. I don't know. I'll go with PS. I'll go with the rounded shape for okay, maybe this is too small, so let's keep this 0.5. Okay, well, looks good. I'm gonna make this as a parameter as well, so that I can control it later. So trail width ratio. Okay. And let's have that right here on the null node. So I think I already have a bunch of parameters that I can control. One is these ramp parameters. And this trail length ratio, as well as trail width ratio. Okay. So though for those two, trail length ratio, trail length ratio, trail width ratio, trail width ratio. Okay. So the basic animation is already being done. Let's try combining these two together. Combining the moving point as well as the outline geometry. Okay, let's try to make it a bit more faster. Okay, so it does look like it's moving, bouncing within the boundaries, and it's looping, and the animation is looping. Now, next step, I am going to create a multiple number of like bouncing balls within one geometry, one cage geometry, and then try the next. And finally, I'm going to try to modify the cage itself when the contact has been created by the ball. I'm going to create some morphing effect to that position, to that contacted position. Okay, so let's organize this a little bit. Here. Okay. That. Okay, so in order to create a multiple number of balls bouncing, I need to determine where should I do that, where I should do that. Okay, so first of all, I obviously need to create a unique path for each curve, for each balls. So I think I do need this part to be looped, creating in a loop. What about this part? This is where it's animating, so I think I don't really need to. Well, it might need to be in the loop, but maybe in a different loop, just to make sure that it runs faster. So let's create this part to be looped so that I can create multiple number of animation path within the same geometry, which is this one. Okay, so I'm gonna create a for each number which is going to cover the loop like this. Okay, now connect the output here to right here, or maybe I can leave it like that. Well, anyway, I think it's fine. Connect it right here. And the output will go here. Alright. Now, in order to create a new animation loop or animation path, what I need to do is to use the detail iteration value coming from for each discount to here to a global seed again to be used in the global seed for this scatter node. That's one way to do that. So let's add additional iteration value to the seed, multiply by some random value here. And if you go outside, then instantly you get multiple number of paths. So in this case I have 10 paths, but if you just want to have 4, 2 or 3, you can do it like that. Yeah, that easy. Now I might want to include these part within the loop. So I'll just place it here. Okay, to make the path cleaner. Okay, the reason why I didn't connect this animation part within the loop is because it's gonna make it slower. If I try that, I can try that, but you'll see that the animations created right here will be slower because it's running inside a loop. So currently there's only 3 lines, so that's fine, but if I increase this to something like 10, you'll see it becomes drastically slower. So that's not optimal. So I should do this outside the loop. Okay, so let's think how we can do that easily. I mean, the reason why it becomes slower is because every time this animation has been updated, all the rest of the code right here is also running together, so that's the reason. So what I would do is to create an additional for each loop and then run this bouncing animations within that new loop. That will make the process a bit more faster. Okay, so currently I have multiple number of paths. So for each animation path, I should create a loop. So in order to do that, I am going to create a primitive ID or path ID, animation path ID to each primitive based on the loop iteration number. So let's call this prim ID, and I should get the info from this for each count too. Let's have a primitive ID attribute coming from the detail. Okay, like that. Then if you check the geometry spreadsheet at a primitive attribute, each animation path has its ID. So this collection of these values will be indicated as a one loop path. Okay, so and the loop that I want to create it here is based on the primitive ID which shares the same primitive ID. So I'm going to use a for each name a primitive for each named primitive node, and instead of using name, I'm going to use prim ID, and then connect this here, connect this here, connect this here. Okay, as a result, I should be moving the point with a decent speed. Okay, looks good. Now let's connect this to here and see if it's gonna work. Okay, so currently only one point is being used. I think I need to fix something. So after this, the line is fine. Okay, so this part is middle point scale. Okay, so obviously this conditions cannot be used because you currently have multiple number of primitives. So I need to fix that. Okay, so maybe I could first of all, I am getting the primitive number, right? Then I could get the point number from that primitive, which should be 3 points. Right, then you can look for the index by finding the current primitive number, point number from that point list, which will be either 0, 1, or 2. And you can use that index to create a conditions instead of ptnum. Okay, so that's the first thing you could do. Now for these one, instead of using 0, 1, or 2, you should use something like a group name. So let's create a group name to each of the point. So point group for the first one, let's call this G0. And for the second one, G1. For the third one, G2. Okay. I mean, you could also do that within this code as well. Then instead of using one, I'll name it as a group name. Okay. So as a result, you should be able to get copied geometry like that. Okay, looks good. Let's make each color random, shall we? I'm gonna use a color node here with the random value. Okay, and if you want to make these faster, you could either shorten the time frame, or you could increase the total number of points to create a path, animation path. If you make it, that's too fast. If you make it to 20, it will be much faster. 15. Some points are going slowly. That is because the total path, the total point number becomes lesser because of the intersection. Okay. Now you might also want to control these point number randomly, maybe creating a threshold from minimum value to the maximum value. So let's also do that. Let's also create some parameters for that. So going into a new node, let's create minimum animation pass point numbers. Zero to 100. Let's duplicate it. In this case, let's call it max. Okay. So let's see, from 5 to 25. I'm gonna copy this, paste it to a this force total count for the scatter node. Okay. Now I want to randomly choose between minimum to maximum. So I'm gonna copy this one as well, the maximum value as well, then use it together with the random functions. So let's say I have a random functions, and I'm going to use a fit 01, fit the random functions, which is in between 0 to 1 to minimum to maximum value. Okay, and for the random value seed, I could copy the seed from right here, the global seed. I think first of all I can use the custom random seed value, as well as this one. Wait. Let's copy this and add it here. Change the multiplication value a little bit. Okay. And that should give you a different value on each loop. Let's check. If I play it, so some points should be slower, some points should be faster. Like that. Now, one thing that I want to change, additional things that I want to change here. as you can see, when the frame is equal to 1, everything is at the surface point, which isn't natural that much. And I mean, at the end of the loop or in the starting point of the loop, it always stops at the surface point. So that looks a bit artificial to me. Okay, so to be able to make it a bit more natural as an animation, I need to shift the starting point positions when the frame is equal to 1. So to do that, I need to go to where I am creating a bouncing animations right here and try to create some value to shift the starting point. And I can do that by just shifting this t value by some random function or random value based on each loop. So let's create the meta node for this loop, connect the meta node to the third input, get the iteration value, and use that as a seed for the randomness. To have some random shift to this t value. Now I have to make sure that this value is within 0 to 1 to be, meaning it has to be a normalized value. I'm going to use the frac function just to get the fraction of this randomness. If it goes more than 1, then you just get the fractional value. As a result, if you're at the first frame, the point has been shifted, the starting point of each of the ball has been shifted, so the randomness becomes a bit more natural. Okay, now it's good. And if I change the seed value, okay, I think it's working. Let's try with other geometries to see if it's still working. I'm gonna create a switch node to switch between different geometries. I'm gonna try with the sphere. I think sphere should obviously work. That's the most easiest shape to solve. Let's make it polygon. Let's also create a cube or box shape. Have enough divisions. Okay. Let's check. So, if it's a sphere, yeah, seems to work. It looks pretty fast. Let's make it 90 frames. Okay, what about box? Yeah, still works. And let's try with other test geometry like rubber toy. Guess should be a little bit bigger. And still works. Okay, that's good. So far everything is working as I expected. Now, the last things that I want to do is to try to modify the geometry, the bounding geometry, the cage geometry to correspond with the inner bouncing balls. So what I want to do is to kind of morph or change the geometry shape when the ball has been contacted to the wall, just like pushing the wall, so that the ball seems like it's wanna go outside of the cage. So to do that, you need to have several informations. One is to determine when did the ball touches the surface. Okay, so I'm gonna go test with the box shapes because it's easier to see the result. Okay, so let's try doing that. This case I need to change this geometry, so let's create a new node, call this cage, and let's bring that cage geometry using object merge. And try to modify this shape. Okay, so the reason why I placed tons of points, tons of grids on top of the grid, on top of the boxes, is because I wanted to modify the shape. I wanted to morph the shape based on the contact from the ball. So more resolutions you have for the cage geometries, more like high-res modifications you could do. Point wrangle. Let's use point wrangle to modify the cage. Now, as an information that I need where is the contact point. So I think I need these point informations, which is moving. Okay, so I'm going to connect this point to the second input. Now I need to make sure that each point has necessary informations in order to calculate how much you should push and when I should push the geometry. Okay, so one of the informations that I could use from this bouncing animation is obviously this F value, which indicates the starting point, where the point is being placed within the line, which is from 0 to 1, which indicates the positions of the point, right? So that's what I would need. And now that I think of, I mean, I should also bring, well, I already have the point position, so that's fine. So let's bring the F attribute. Okay. What else? I think I also need the directional value as well. Directional value will be used to determine in which directions the K geometry should be modified, should be pushed. Okay, so that could be this directional value that I have it here. right? Right. Let me check. Let me check how have done it previously. Yeah, I think that's how I did it. Think so. I think so. I realized that I think I need additional informations other than directions because what I want to do is when the ball touches the wall like this, I want to move the wall like this, meaning moving to this directions. So I need two vector informations. One is the one that goes this way and one that goes this way. Right? So yeah, let's get those two vector informations, and combining these two informations I should be able to get a blue vector value where the wall should be pushed to. Okay, so going back to the bouncing animations, let's get additional vector value, which means I need to get the next line informations, meaning n+1, and do the similar calculation like these to get this next direction. Okay, so int npts prim points n+1. Now I need to make sure that it goes back to not 0. Then point npts 0. pts1. Okay, then the next directions is n+2 minus n+1. Alright, so now I have direction 1 and direction 2 or current directions and the next directions. Let's have both of them to an attribute. Okay. So I guess that's about it for information that I need. What else do I need? Let me see. What do I need as an additional information? Yeah, probably that's it. I think. Probably. Well, okay, so let's try with these informations that I have. F directions and N directions. So let's retrieve those informations within this node, within this point wrangle, in order to modify the cage. Okay, so since I have multiple number of points coming from the second input, I'm going to deal with each of the point using for loop. Okay, and I'll get the necessary informations like f, like direction, and direction, okay. Now the actual directions that I want to move the face to, or the point of the cage to, is direction minus n direction, and I think I also should normalize these, and also finalize, do the normalization again. Okay, then I should also decide the movement amount, but let's decide it later. This is the base vector value for moving directions. Now let's also calculate the distance from the current point position of the cage to each of the point. So I need to also know the point information, point position of each point. Okay, so the distance is distance between the current point position to the pause, the point position, the moving point position. Okay, now let's determine how much of the area will be picked using this distance as a threshold. So I'm gonna create a scale value by remapping the distance, which is from 0 to a capturing distance. Let's call this cap dist, and if it's close to 0, let's make it 1 as a scale value, and if it's far away with this threshold value, then make it 0. Okay, and this will be the threshold for the distance. Now I could try to move the point position to a moving direction based on this SC value plus multiply by some pushing amount, the maximum moving amount or push amount. Okay, I think I still don't have a contact information used, but let's see what will happen with these. Okay, should be distance. So if I play it, okay, nothing seems to happen. If I increase it, nothing's happening. So it's moving. So maybe I'm doing something wrong here. Let me see. So I'm using point wrangle for the cage and points getting from the second input, point F. Oops, gotta be N direction. Okay. So this has to be negative. So it does seem to modify the shape, pushing the shape. So this cap, by increasing this cap distance, you are changing how much of the area will be affected by each point. Let's play this slowly. To see if it's correct. Can't really see. Let's combine this with actual balls. So it's kind of a pulling a little bit too much here, so maybe I should okay, maybe something is not correct here. Let's create the amount. Okay, it's going the other way. It's kind of a pulling. So once it touches, that's fine, but something isn't correct, is not correct. So why this is happening here? Let me see this. Let's make this slower. I'm gonna make it 240 frames, so that'll be easier to see. Okay, so this part is obviously something weird. It's let's decrease the number of points. It's a bit hard to see. So let's have only 1 point. Okay, this is not correct. But this is correct. So this is fine. So this is where it's something wrong with this part. Going from this point to okay, so let me see. Let me check the current vector value for that point. Let me see. So when touches here, the next direction's going and this way. So probably that's the reason. Okay. So the contact, the morphing should only happens when it's somewhere around here, not while it's moving. What if I do like this? Huh. Okay, I realized that this has to be negative and this has to be positive. Okay, now this part is wrong. Huh. When it touches... okay. So as soon as it goes to look for the next point, this is where it gets weirder. So maybe the way I write it like this is not really good. Okay. What should I do here? Because as soon as you get to the next line, the direction just drastically changes. So yeah, obviously it's not a good idea to use this method. Alright. Well, maybe I can just, instead of using the moving directions, I can just move the geometry, move the surface related to the current point positions. So, meaning the moving direction will be at P, negative position, normalize. This might be better. In this case, you should be plus. Okay, a little bit better. I mean, doesn't really look natural anymore. So after setting up capturing distance, I think I need to make the scale like power of 2 to make it a bit more natural in terms of the scale, to make it less spherical modify. Okay, now I also need to modify that so that while it's moving like this, while it's moving in between the lines, I should not have any modification like this. Currently I'm just using distance to determine whether I should morph or not, but I need additional information so that while it's going from end to start to end, in the middle part you shouldn't have any modification like this. That's where I can use this f value. Right. Or instead of using f, there is another value that I've created, I mean related to f, but using this u ramp parameter. I have this u value here, so maybe might be better using u value for this purpose. So let's try to get a u value. Okay, then try to use that value to indicate only the starting point and end point will be having a morph shape like this. So I can modify this u value, which is in between 0 to 1. Let's create a angle value by multiplying u by pi, then using sine functions to create a kind of a mountain-like shape, then multiply it to this one, see what happens. Now I still see some mountains in between. What if I change this to F? Still not good. Okay, I think I need to, oops. I need to reduce the range. So let me see. I think I need to remap this u value, which is in between 0 to 1. Wait a minute. I only want to have a scale happens on the end, not in between, or maybe even on the starting point. So let's try with these. I think it's the other way around. Point 0.6 to 1.0. Huh. And wait a minute. I think I need to do it like this. Huh. I don't really wanna. What is it? It might be okay. Let me see. Let's make it faster. 60. It's a little bit too fast. Okay, so I kind of want to have mountain-like modifications when it touches, but it's happening within at this range, so this is obviously wrong. What about just using u as it is? I think I still want to use sine functions, but subtract by 1. Okay, looks better. Okay, looks better. Now, let me see. Now in that case, I think I didn't really need the fifth function. Now, one things that I want to have currently, because I'm using this moving directions functions, which is just a subtraction between the current point positions and the goal positions, you're getting kind of spherical shape, spherical morphing shape, which is, I don't know if that's fine. This looks too spherical. I might not like it, but how can I make it a bit more flatter? Does this make sense? Change? Yeah. This does makes a little bit of change, but not good enough. Okay. Well, what I could think of is instead of updating the point positions at this point, I'm going to create a move function, move vector value here. Update the move vector value. Promote it to a attribute and use attribute blur to blur the move value. Then in the end, use the blurred move value to update the point position. That will smoothen the movement, the morphing effect a little bit better. Yep, looks better. Okay. Okay, this way I think I could increase the capturing distance, and if I increase the smoothness, you could make it flatter. Yeah, looks better. So a little bit more parameter to control, but the effect is fine, if it looks fine. Now let's increase the number of points to see if it's gonna work multiple. With the multiple number of points, yeah, seem to work. Cool. That's a lot of points. Yeah, seem to work. Okay. Looks looks like I'm getting in the final step. So I think everything looks fine at this point. I mean, some of the points sometimes collide like this, but if you want to avoid this, then you have to go back to where I'm creating a path, animation path. But I guess you could do that. I mean, with some conditions. I think I'm not gonna go through that. Okay, let's try with the rubber So it works with the big head. It works with the, oops, well, that's a lot of and you could always come back to here to kind of control how much it affects the movement. Okay, well, anyway, these should be parameterized. Okay, so cage more. Okay, so I think I have all the setups now. Let's try to organize this. So as an additional parameters, I have this one, cage capturing distance, as well as gauge push amount. Okay, and the smoothness, gauge push smoothness. What else? Switch node, shape, type. Currently I have 1, 2, 3. Okay. I think that's pretty much it. Anything else that I have as a parameter? I don't think so. So let's try again. So there are several parameters like the size of the ball, random seed. Let's also use this to change the color as well. So random seed changes the paths and the colors. Fuse distance is a minor thing. The minimum animation path. So this indicates the number of control points for the animation path. So if you increase this, you get faster. I mean, you get more paths within the frame, the animation, the loop, one whole animation. So you more paths you have, faster the point moves on each line. Okay. This indicates how the point moves within one line. So changing this could also be interesting. Anyway, I think I like this. And this indicates the line, the cylindrical, the capsule length shape. When does the controls the timing? When does the sphere convert becomes a cylindrical or capsule-like shape? I guess I like this profile, so I wouldn't change it. Trail length ratio. So this indicates the length of the trail. If you make it too long, it will penetrate the geometry, so it should be less than something like 0.7. Trail width ratio. This indicates the capsule width. If it's 1, the sphere and the capsule is the same shape, same size. If it's smaller, when it's running as a capsule, it becomes smaller in terms of the width. Yeah. Cage capturing distance is determine how much each area on the cage will be affected by the closest point. If you increase this, you have more effect by the point. And the cage push amount is how much the cage will be pushed, moved by the point. And the push smoothness gives you some smoothing for the pushing the mesh pushed result. To make it if you want to have more natural pushing, then having this higher value might make sense. Let's check with the box. Yeah, this is the easiest. This is the most clear way to see the result, I guess. If you have less capturing distance, you only a partial part mesh will be affected by the point. So combining these three parameters is kind of essential to see your desired effect. Okay, and that's pretty much it, I guess. Let's also have some, I don't know, maybe a contact color informations to the cage, and I'll finish this live stream, which isn't that hard. I think I can just go to the cage modify here and apply, use some of the value, something like this one for the color. Okay, so let's create a attribute called color, and something. What should I use? So maybe I should use something around here. Instead of without the move direction, because this is a vector. Okay, so let's see what would I get with these value. I'll just place the color node somewhere around here. Look for the call attribute. Make this blue. Since I have a alpha channel, it's a bit hard to see. Okay, not bad. So this could be in a contact color. I mean, could be also a gradient. Nope, not that good. Maybe only these parts are being used. I'll just want to get back to the one that I created. Yeah, it's fine. Okay, so this is it. Let's increase. Yeah, well, I hope you learned something new. I mean, The idea itself is pretty simple. I mean, some of the idea could be used in some advanced way. I mean, something in different ways, so it might be useful for some of you if used in different case. It's just blacked out. Let me just create a principal shader. One for the sphere, one for the cage. Okay, and both of them I'm going to make the color white. Okay, so for this one, use sphere. This one, use cage. Okay, that looks a little bit cleaner. In terms of the preview, I mean. Alright. Okay, wait a minute. Okay, looks fine. Let me check the comment more about Grasshopper, please. Oh, I didn't know if someone would actually look at the Grasshopper videos. Well, if any topic you're interested, I'd love to. Maybe it could be a music visualizer if the bounces time to music frequencies. That will be really interesting. I do want to create a kind of a sound visualizer, audio visualizers. But I was wondering if Houdini is the best medium to do that. I mean, since sound requires real-time processing, maybe I thought something like softwares like Touch Designer might be a better suit with those. And yeah, I am studying Touch Designer right now. Not really good at using those, but I saw that Touch Designer, I used the experiment version of the Touch Designer, and it uses a similar data structures as Houdini, like an attribute. It does have an attribute data structures and new context on Touch Designer, and that seems to be really flexible enough, and I believe I can do the same things that I have just done here on Touch Designer using that new context, the pops context. So maybe I should start using a Touch Designer as well, seriously, since it's getting closer and closer to how you can deal with the Houdini, which looks pretty fun. Yeah, so that's my plan. Yeah, it is fun to mix with webcam, all the censoring datas. Yes. Okay. Actually, I realized that, I mean, a lot of people seems to create a really cool effect by just using few nodes. Looks pretty fun. In order to make this kind of effect, I'm kind of have to do this whole node set. It's not really efficient at all, but I do realize that. Anyway, that's to practice. Okay, so this is it for today, I think. Let me know if you have any feedback or comments. If not, I will finish this live stream at this point. As always, I'm going to upload the files that I've created during the live stream, and you can download the file later. I'll post a link to a video description to this YouTube video live stream, so you can come back later to download it, to check the file if you need it. Okay, and yeah, that's it. I'm also doing a Patreon page, so if you're interested, please come visit. Okay, that's it. Good night. Thank you for coming. See you next time.